Perfect, thank you. Okay, so we can start. So first of all, thanks for coming to this session in which I will discuss Java within the serverless space, so within the function as a service space. Before, some logistics. So my name is Delabassée. Despite my French accent, I'm not French. I live in Belgium, where I work for Oracle. So I live in Belgium, in the French-speaking side of Belgium, and I do report to a team in HQ, California. This was me some time ago in a conference in Sweden, and someone tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. This is a real conference, so please enjoy. And last but not least, I'm using those new MacBook Pro with the new butterfly keyboards. Anybody is using that kind of laptop, new MacBook Pro? And do you enjoy the keyboard? Well, kind of. So anyway, those keyboards are broken. 2 weeks ago, Apple has fixed that keyboard for the fourth time, and it still doesn't work. So if today any of my demo fail, it's not because of me, it's because of the broken keyboard. And I'm serious. Okay, let's get started. Serverless. So first of all, I need to clarify what I mean by serverless, because serverless is a very broad term. Whenever I say serverless today, I really mean function as a services, FaaS. And let's try to define what FaaS is. So first of all, we have this notion of a function being a very small piece of code that will get something in input. So basically, the input will trigger the function execution, the function will perform its task, and it will produce most of the time an output. So a function within the FaaS space is not necessarily a function as we have in mathematics, in the sense that a function might also have some side effect, like putting a result in a database, for example. At the end of the day, you developer will basically spend your time writing function. So you will write those very well-bounded piece of code that will perform single well-defined task. And finally, we have this as a services piece, which is basically the platform, which is the compute element on which your function will run on. So you, as a developer, will write function, and you will basically give those functions to a platform. And it's then up to the platform provider to make sure that everything works. So that includes provisioning the platform, installing, maintaining, securing the platform, scaling the platform, and so on and so on. So basically, FaaS gives us this ability to write and run code without having to worry about the underlying platform. So that means that we can easily distinguish two types of role. On one hand, we have function developers who will develop and write function, and on the other hand, we have the FaaS platform provider who will basically have to take care of all the underlying platforms. Now, this is a pretty new space, but if we look at on the market, there's a lot of momentum going on for serverless, and more specifically for FaaS. And then we most of the time have this question, okay, should we go containers or should we go towards a more FaaS-based architecture? At the end of the day, it doesn't really matter, because if you are looking at all the FaaS platforms, they are all using containers. Either explicitly, you can see that under the hood containers are being used, or they are using containers implicitly. So you don't necessarily see that containers are being used. So let's now discuss serverless Java, the topics of the discussion today. So I think that we can all agree that Java is a very popular programming language. Depending on where you look at, Java is the most popular programming language, or is the second most popular programming language. It doesn't really matter. At the end of the day, I think that we can all agree that Java is very widely used. We then have this new emerging space, which is the function as a services space. And we don't have a lot of metrics, but clearly the metrics that we have regarding the Java usage within the FaaS space are not that great. So this was a survey that was conducted by the Serverless Frameworks. And so basically the Serverless Frameworks is an abstraction that runs on top of existing FaaS platforms. So it gives you the ability to write function using different type of language. So they ask their users, what programming language are you using today to write your function? And basically, you see that we have this big green arc, which is Node 6, just above 70%. If you add that to Node 4, basically over 75% are using Node and hence JavaScript to write serverless function with the serverless frameworks. We then have Python 3.6, Python 2.7, so roughly 15% are using Python. And you see this little yellow box at the top. It's basically the Java usage within the serverless frameworks space. And it's not even 5%. So it's pretty low. Not only that, we see that basically it doesn't really grow. So the first question is, what are you using today to write your function? And this question is, what do you plan to use in the future to write function? And basically, you see that Java is very flat, around 5%. So again, we don't have a lot of metrics, but clearly the few metrics that we have are not that great for Java within the fast space. So how can we explain that? On one hand, we have Java, a very widely used programming language, and on the other hand, we have this emerging space where clearly Java is not widely used at all. So we might want to look at the historical fast landscape. It's a pretty new landscape, but if we look at the three major fast platform providers, that is Amazon, Azure, and Google, well, we see that for Amazon it's okay, because they are supporting Java 8 since 2015. So on Amazon front, it's good. For Azure, it's not that great, because they are only supporting Java since February this year. So basically, it's a new offering. And on Google front, well, it's worse than that. They are only supporting Java since April of this year, and it's only Java 8, and it's only in alpha. So it's not even commercially supported. So the fact that if we look at the major fast platform providers, well, except Amazon, the other two incumbent players in that space, they don't really have a very good Java story. So that might explain partly why Java is not that widely used today. Then it's a trend that we have seen since many years. We see that basically startups are using any type of technology to basically build their services, and it's only when they need to grow, when they need to scale, when they need to mature, that they're switching to Java. So over time, we might expect that some users that are using today something to write serverless function, we might expect those users to switch over time to Java when they need to basically grow their services. Now, something else that might explain why Java is not very popular in that space, it's maybe Java is not a good fit to write serverless function. So serverless functions are by nature short-lived, so they will be invoked, they will run for 100, 200, 500 milliseconds, and then they will die. So functions are ephemeral, so maybe Java is not a good fit for writing such a short-lived application. We all know that Java has been designed and tuned for writing a long-running application, and maybe from a technical standpoint, it's not a good fit. So at Oracle, when we started to work on our fast platform, we wanted to make sure that Java can be used to write serverless functions, that Java can be used as the default language for writing serverless functions. So we basically set ourselves some kind of goals, some kind of thing that we would like to achieve when it comes to write serverless function with Java, like the ability to use plain old Java, the ability to use existing toolchain, the ability to build also complex applications, and so on and so on. So that's basically what we will go through today. To illustrate that, I'm going to discuss FN, which is an open source container native fast platform. So it's open source, Apache v2, everything is on GitHub. One of the benefits of an open source fast platform is that as a user, you can basically take the platform and run it on any cloud. So technically, Oracle is using FN to power its managed fast platform offering, Oracle Function. But given that it's open source, you can take FN and run it on top of Google Cloud, on top of Amazon. It doesn't really matter. Everything is out there. Now, if you are doing that, that basically means that you will have to deal with the two roles. You will be, on one hand, the function developers, but you will also be the fast platform providers. And there are some use cases where it makes sense to have the two hats. Anyway, if you understand that, because clearly running a fast platform has a cost, if you understand that, that's perfectly fine to do that. So FN is container native, meaning that under the hood, FN is using containers. So basically, everything is FN is simply containers. So you write a function, it will be turned into a container. Now, as a developer, you don't necessarily need to understand how containers work. All the FN toolings will basically handle that for you. Technically, FN is written in Go. Well, FN is using Docker. Docker is written in Go. FN runs on top of an orchestrator, such as Kubernetes. Kubernetes is written in Go. So for such a kind of infrastructure project, it makes sense to use Go. But as I said, we wanted to make sure that Java would be a first-class citizen on top of FN. So let's have a look at FN in action. So the only thing that you need to have on your machine to run FN is Docker. So I have Docker running here, and there's nothing running in there. So I'm going to start FN using the FN CLI. So you see this FN command is basically your interface to FN. So I'm starting FN in detached mode, and if I look now, I have FN running within my Docker. So the next thing that I want to do is bootstrap a function. So I can say Go, I can say Go, Node, Python, and so on, but given the topic today, obviously we're going to use Java. So by default, if I say Java, it will be a Java 11 function. And then I need to specify, I need to give my function a name. So if we look at what has been created for us, we have two classes. So hello function is basically a simple hello world serverless Java function that you will be able to extend. We then have this hello function test, which is basically a class that is using JUnit to unit test your function. And then we have two files here. So we have a pom.xml, so that means that in FN, a serverless Java function is simply a Maven project. And we have this func.yaml file. So a func.yaml file is basically a file that contains some metadata about the function itself, like the name of the function, the version of the function, the runtime to use, and so on. And you see at the bottom, we have this com.example.fn and so on and so on. So this is basically the entry point of our function. So given this is a Java function, this is basically the class and the method within the class that correspond to our serverless function. So we have a POM, so that means that we can, for example, use Maven to test our function locally. And obviously, the tests are passing. So the next thing that we want to do, we want to run this function locally first. So for that, we need to create an application. So FN list apps. I have a bunch of applications. So an application is simply a namespace, a way to group together related function. So let's create a function called JNation. And if I look, so FN list function within JNation, it's empty. So now we can deploy this function. So FN deploy, the function is JNation. I don't have to specify the function because I have a local func.yaml, so that one will be picked up by default. And we can add a -v to see what's going on behind the scenes. And well, you see that basically behind the scenes, Docker is being used by the FN tooling to basically take the Java code of the serverless function, compile it to a jar, and basically inject that jar in a runtime container image that will be then pushed to the registry that is used by my FN infrastructure. So now, if I list again the function, within my JNation application, I do have one function, the Duke function. So that means that we can invoke that function. So FN invoke JNation, that's the application, and then the name of the function, Duke. And it's a hello world function, so it's pretty basic. There's nothing very special there. So you see, I'm using the FN CLI to invoke the function, but obviously what we want to do at the end of the day, we want to invoke the function using triggers. And most of the time it will be an HTTP triggers. So if we inspect the function, so JNation, Duke, we see that we have an HTTP endpoint that we can use to invoke the function, and we can also define additional triggers, like an HTTP triggers, or, different type of triggers that are supported by the platform. So my function is running locally on my FN server on my machine, but obviously at the end of the day, you want to deploy the function within the cloud. For that, you just need to switch to a context, to a different context. So FN use, and I'm going to use the Oracle Cloud context, so that's basically a data center in the US. If I look at the apps there, I don't have the JNation app, so FN create JNation, FN create JNation, And if I deploy again my function, now it will be built, well, everything is cached, and now the last step is basically pushing the Docker image of the serverless function to the registry that is used, in this case, within my Oracle context, OCI context. So if I inspect again, we'll see that, well, it takes a bit more time because I have to go through the network, and you see that we have a different HTTP endpoint. So basically my function is running in a cloud in the US. So just to save some time, I'm going to switch to the local context. So let's see. So what we can do, so we can have a look at the function itself. So given that it's a Maven project, I can use my ID. So it's importing. Okay, hello, Duke source, hello function test. So this is the test for the function. And if we look at here, main, hello function. So this is basically our basic function that we can extend because nobody's in the business of writing hello world. So you see, it's a Java class. In this case, it has a single method. So that method is the one that is referenced within the func.yaml. So that's basically our serverless function. And in this case, it gets a string in input and it produces a string in output. The thing that you should notice here is that there's no interface, there's no annotation specific to FN. So it's really plain old Java, nothing else. And obviously, given that it's Java, we can do something like this. So let's see if I can type. So an event has a date and a name. We need a constructor, we need a default constructor, and we need getter and setters for our two fields. So I have this new event type, which is pretty basic. It has a name and a date. So what we can do now, we can create an event object. Oops. Let's use the input as the name and the today's date. And now I can return that object. And obviously I need to update the signature of the function. So now the function is getting a string in input and it will produce this event type. So let's deploy that. So JNation, and I'm just going to use the -local flag to save some time. So basically, I will not push the image to the registry once everything is done, given that everything is local. So the build failed. Anybody has a guess why? The test, yes. Each time we build a function, we're testing the function, and obviously my tests are not passing, so I need to fix that. Wait. I'm sharing a trick here. You'll see it should work. You see, it works. The tests are good. Clearly, that's a joke. Don't do that at home. That's only something that you can do when you're in front of an audience. But you get the idea. So let's invoke that function again. So fn invoke, and so the JNation, Duke, and I have the ability to pass it some payload, obviously. So JNation, let's say. Well, doesn't work. So you remember at the beginning I told you that the keyboard is broken, and here, this is not a space. This is just something that is not a space. And it took me a lot of time to figure that out. So you see, that doesn't work, but now, so this is now a space, and it works. So I was not lying when I said that the keyboard will broke my demo. No, but that's not, it's recorded. So let's GQ that. So this is now the output of the function. So basically, we're passing a simple string, and what we get in output is this new event type, which is automatically converted by the platform into JSON payload. And again, if we look back at the code, you see that there's nothing specific here to FN. I mean, there's no Java type to JSON conversion and so on. So this is one of the things that is provided by the Java FDK. So we have multiple function development kit, including a Java function development kit that give us JUnit support, Maven support, input and output coercion. So I've used the output coercion, but obviously I can use the input coercion, so I can pass any type of JSON document and automatically it will be converted to a Java type, and so on and so on. So, the ability to use plain old Java, I think that we can agree that you saw that I was using Maven, I was using IntelliJ, you can use NetBeans, you can use Eclipse. So we can also use the toolchain that we are using night and days. Now, let's quickly talk about the ability to build complex applications. So, I told you at the beginning that functions are ephemeral. So basically, they will live for a very short period of time. So that means that if you need to hold some kind of state, you shouldn't do that within the function. It's just too expensive. You cannot connect to a database within the function because the function will live for, let's say, 300 milliseconds, so don't do that. You need to hold the state outside of the function. Having said that, there are use cases where it makes sense to hold the state within a function. And that is when you want to compose together multiple functions. So the idea is the following. So you have a main function that will invoke another function. Given that we are going through the network, this is an asynchronous invocation. That might take time. Once we have the result, the main function will do something. Either it will invoke another function, or it will do something else, or maybe the function invocation failed. So the main function will have to react accordingly, because again, we are going through the network. So for that, we have in FN a capability that is called FN Flow. It's basically an API that allows us to do function orchestration. From a programming standpoint, it looks very much like the completion stage API that we have in the Java platform. So in the Java platform, we have this completion stage API that gives us the ability to basically define pipeline execution of asynchronous tasks. The FN Flow API is exactly the same. The major difference is that the completion stage API, everything happens within the JVM, so within a single process. The FN Flow API, we're talking about function invocation. So basically that means that we have to go through the network to invoke those functions. But from a programming standpoint, it looks exactly the same. So this is how it looks like. So we just need to have an instance of a flow object, and then we define the pipeline execution. That's what I'm doing at the second line. So I have this stage object. Then I'm using the flow to invoke a first function. So afunc is my first function. And then I'm doing something with the result. And the stage object will basically contain the result of that invocation in the future. It will contain the result, or it might contain also some error, because again, things might go wrong. So here, we're just defining the pipeline execution. We're not doing anything else. And it's only when we are doing a get on the stage object that basically we are triggering the platform. So that's where we tell to the FN platform, okay, execute this pipeline execution for me. So to illustrate that, the canonical trip booking scenario where we basically want to book a flight, we want to book a travel. That means that we want to book a flight, an hotel, and a car. And finally, at the end, we also want to send a confirmation to the user with all the details. So what I'm going to use here is the trip booking function, which is written in Java using the FN Flow API, and basically it will compose together multiple backend functions, one written in Java, another one written in Ruby, and so on, to book the trip that we want. So, let's see. So first, if we look at the app that we have, so there's this travel app, FNLS. So within the travel apps, we have a bunch of functions. So you see we have a car booking function, a car cancel, and so on and so on. And the function that I'm going to invoke is the trip booking function. But that's basically the function that is doing the orchestration. So before, I just need to do a bit of preparation. So here I'm taking my platform provider hat. So if you are using a managed platform, that's something that you don't have to take care of. Typically, the flow server will be managed by the fast platform providers. So I've started 3 additional containers. So we still have, obviously, FN server that is running. What I started in addition to that is the flow server. So the flow server is basically a server that is adjacent to the FN server, and the flow server's role is basically to manage the state of those function orchestration. And then I have 2 additional containers that are just used for my demo to help us to see what's going on behind the scenes. So the next thing that I want to do, I need to make sure I configure all my function. So I have some sample payload that I will send to my trip booking function to basically trigger the execution. So basically so that will trigger the booking of a complete trip. The thing is that it's not super visual, so that's why I have these additional containers running that will help us to see what's going on behind the scenes. So let's see. So I'm going to pass that payload to the travel application, and I'm going to invoke the trip. No, it's the trip function within the travel application. Travel is not a FN command. It's not. Oops. So if I invoke travel trip, it should work. And if we go here, well, we can basically see what's going on behind the scenes. So we're booking a flight, we're booking an hotel, we're booking a car, so everything is great. And finally, we are invoking this function to send an email to the user with all the details of the booking. So you see here that basically the first time it took like 3 seconds, almost 4 seconds to book a flight, 2.6 seconds to book an hotel, and so on. So this is quite expensive, right? So let's invoke it again, and we should have a different behavior. Well, it's a little bit faster, but it's not that faster. Yeah, it's way faster. So the thing is that when we invoke a function, the FN platform is keeping the container that is running that function hot. So the next time that we have we have a request to run that function, the container is already there. So the platform doesn't have to start the container because this is an expensive operation. Obviously, at some point in time, those containers will time out. So this is one of the things that we are doing, like any other fast platform providers do, to reduce the start time of your function. So this additional server helps me to basically make sure that my demo can fail. So each time now I'm going to try to book a car, it will just fail. So that was the happy path, and let's try to book a trip again. And we should have a different behavior. So yes, we can book a flight, we can book an hotel, we cannot book a car. So basically what this demo is doing, it applied the saga pattern to basically roll back all the booking that we have done. This is something that we can easily do with the FN Flow API. And basically we are using the backend function to cancel the flight, to cancel the hotel, and so on and so on. And once we are done, we are invoking the email function to send a mail to the user telling him, okay, sorry, we're not able to book your trip. So that's in a nutshell what the Flow and the FN Flow API provide, the ability to orchestrate together multiple functions. So back to the slide. So with serverless Java function, we have the ability to build complex applications. Now, the FN Flow API is not a generic API. It's only when you need to compose together multiple functions that it makes sense to use the FN Flow API. So yes, we can build some type of complex application, but obviously I'm not saying that you can use serverless function to build any type of application. That's certainly not true. Now let's discuss about the latency and the performance that we do expect from serverless function. So regardless of the fact that our serverless are written using Java, we want our function to be invoked as quickly as possible. And remember that all the fast platforms are using containers under the hood. So basically, what we want at the end of the day, we want our container to start as quickly as possible. Now, when it comes to Java, there's something else that we do expect from Java, and basically we want Java, so the JVM, to respect the environments it runs in. So I'm not going to go over that slide because it's very busy, but the takeaway of that slide is basically, if you look at the evolution of Java since Java 8, so till today Java 12, basically with each release we are doing the investment to make sure that Java and the JVM can work nicely within a container environment. And that's obviously something that is key for us because we are using container in the fast platform. For example, very quickly, Java, the JVM has the ability to auto-tune itself. So when you start a JVM, basically the JVM will look at the environment it runs in, so the number of CPU, the available memory, and basically it will try to come up with some default value that should give decent results when it comes to performance. If you are doing that within containers, and if you are not using a recent version of Java that supports containers, basically the JVM that is running within containers will use the metrics coming from the host and not from the containers. So let's say you have a host that has 32 CPU, and you are running on that host a container with Java inside, and you allocate just one CPU to your containers. Well, the JVM will see that it has 32 CPU, so it will basically try to tune itself using that wrong 32 metrics. And you can expect to have some very bad behavior very quickly. So again, takeaway is that basically we are doing the investment within Java platform to make sure that it can work nicely when it runs within containers. And obviously, if you are using a platform such as FN, we are basically doing all the tweaks on the tooling itself, so that you don't have to specify any specific JVM parameters for your functions. So when it comes to starting fast, when the Java applications run into containers, there are multiple tricks and techniques that we can use. One is CDS, class data sharing. It's something that is available since Java SE5, and basically CDS provide the following. So whenever you start an application, a Java application, the JVM will unpack the jar, it will load the class into memory, but before we have an in-memory representation of all the class, a lot of operation need to be done by the JVM on the class itself, on the bytecode itself, like security scanning and so on and so on. CDS is about doing that only once. So the JVM will basically do all that work on the classes, and once we have an in-memory representation of all the classes, the JVM will take a snapshot and will dump that to disk. So that the next time the application starts, the JVM will load that dump directly into memory, so that it doesn't have to go through all those operations again and again. And basically, just by using CDS, which is available since Java SE5, so nearly 15 years, you can reduce the startup time of any Java application by roughly 25%. So that's something that obviously we're using on the serverless side. Again, you don't have to do any tweaks for that, it's something that is managed. Now, CDS is now also available for the classes of your application. Since Java SE 10, you can do that snapshot of all the classes that are composing your application. On the serverless side, application CDS might not provide that many benefits, so we're not sure if we're going to use application CDS. But CDS, for sure, we're leveraging that. Now, when it comes to startup time, we have to think again on the fact that we are using containers. So basically, what we want to make sure is that our containers are as small as possible for any type of language. And this is something which is important on the Java side, because Java tends to be a little bit fat when it comes to run times, right? So there are multiple things that we can do to basically reduce the size of the container image. And we need to make sure we do that, because each time we start function, the function has to be loaded from the registry, and obviously we don't want those Docker images to be multiple 100 megabytes large. That's just too big if we want to have a decent startup time. So if we look at a serverless Java application, there are three types of layer in the container. There's the Java function with all its dependency. So on that front, there's not much that we can do at the platform level. The only thing that we can do is give you advice. Watch out for your dependency. Watch out for the transitive dependency, and so on. Don't bring any dependency if it's not needed. Those kind of best practices recommendation that we are giving. But when it comes to the Java runtime and the operating system layer, there are things that we are doing. So the first thing that we are looking at is basically we want to use a lighter operating system layer, such as Alpine. So Alpine is a security-oriented, lightweight Linux distribution that weighs just over 4 megabytes. So basically, Alpine gives us a full Linux distribution with just the thing that we need to run our code. The issue that we have today is that Alpines rely on muscles, and OpenJDK rely on libc, on glibc. So basically, the standard library that is used between the C++ code of the JVM and the operating system layer are different. OpenJDK is using glibc, and Alpine is using muscles. The good news is that we have Project Portola, whose goal is to build OpenJDK on top of muscles. So with Portola, we can use OpenJDK on top of Alpine. So that's one thing that we can do to basically reduce the size of our layers, at least at the operating system layer. Now, at the Java runtime layer, there are things that we can do for sure. So we can use the modularity that has been introduced in the platform in Java SE9, and more specifically, we can leverage JLink. So JLink gives us the ability to basically create a custom Java runtime that will only use the modules that are needed by our code. So to give you some idea on the benefit that we can get. So first of all, if we look at a full JDK, so JDK 12, it weighs around 320 megabytes. Now, to run Java function, you don't need a JDK. You simply need a GRE. That's something that we handle for you, but that's also an advice. To run code in production, you don't need a JDK. You should rely on GRE. You don't need Javac to run your code, for example. So, if we look at the GRE, there's no JDK 12 GRE, but to give you some idea, I've used the OpenJDK 11 GRE Slim distribution, and the JDK itself weighs 220 megabytes. So just by switching from JDK to GRE, we already save 100 megabytes. So that's already a huge win, right? Now, what we can do with JLink, we can create our own GRE. So again, to have some idea, I've created a GRE that is using all the modules. It's a very stupid idea, because I don't think that there is a technical way of writing an application that is using all the modules, but this is just to give us some idea. So if we do that, we have a GRE that weighs 170 megabytes. So that's all. That's another win that we can have. We can remove from that GRE, we can remove information that might not necessarily needed, like the headers files, the man page, and so on. If we do that, we save another 25 megabytes. We have two levels of compression, so if we compress that to the max, compression 2, 83 megabytes. So basically, we're saving another 60 megabytes. So you see that just by using JLink, well, we basically went from 270 megabytes to 83 megabytes. But obviously, we want to use JLink as it was designed for. We will use JLink to basically create a GRE with just the modules that our serverless Java function needs. If we do that, we're going down to 47 megabytes. And obviously, we can remove information such as header files and so on, 41 megabytes. And we can still compress that to level 2, 32 megabytes. So basically, 32 megabytes give us a GRE, so a Java runtime that includes all the modules and just the modules to run our serverless Java function. So in a nutshell, JLink provides a quite important benefit when it comes to running serverless Java function. Now let's have a look at how you can use JLink and Alpine within FN. So I'm going to create a function, but this time I'm going to use a different approach, init image, and I'm going to use, JLink init, and I'm going to call that function JLink. So basically what I've done here, I've created a simple Java 12 function that is using JLink. So let's deploy that function. So fn deploy JNation JLink. Let's see, minus verbose and local. So our function is deployed, and you see that here, basically, we're using JDEPs and JLinks to create this specific runtime. Obviously, we can invoke that function, so JNation JLink, And it's a pretty basic function. It's a kind of hello world, so you give it a day and it will basically use the new switch expression statement of Java 12 to do something. It's not really the point. What we can do, we can look at this function. So given that it's a container, so I'm going to use Dive. Dive is a very nice tool that helps me to see what's going on within my Docker containers. So we see that we have a first layer that weighs just over 4 megabytes. That's basically Alpine. We have a 2.4 megabyte. That's basically the function here, so function.jar, and all its dependency. So 2.4 megabyte. And then we have this 33 megabyte, which is basically our custom GRE. So 33 megabyte gives us a GRE that contains enough modules to run our serverless function. And finally, we also have this 20 kilobyte, which is just a share object that's needed by the platform. So if we look here, we basically have a 40 megabyte that contains the operating system, that is Alpine Linux, that contains the Java runtime, and that contains all our function with all its dependency. And if we see, that's something that is key when it comes to startup time of the function itself. Because that means that the infrastructure just has to load those 40 megabytes instead of 300 something if we're going to use a full GRE. And to do that, you saw that basically I only had to use this init image capability of FN. So I didn't have to specify how JLink should create my GRE and those kind of things. We can go further than that. We can use Graal to basically try to still reduce the size of our layers. So Graal is an open source universal virtual, open source high performance virtual machine developed by Oracle Labs. It provides many benefits, but there's one benefit that is very useful within this context, and that is basically the native image capability. So the native image capability gives us the ability to take some Java bytecode and turn that into a native executable that will run on a target platform. That will reduce the size of the whole GRE, because the GRE will be embedded directly within the native executable. And it will also improve the startup time, because we have less things to load, and it will also reduce the memory footprint. To do that in FN, it's pretty straightforward. So, same command, but this time I'm going to use native init. And I'm going to give a different name to my function. So my function has been created, and well, to run that function, I need to deploy it. Fn deploy. Now that deploying this function, means that we need to build it. And to be honest, the build is quite expensive. It takes like 2 minutes, because we basically need to start from Java bytecode, and Graal will turn that into a native executable. Anyway, it works like that. And yep, that's all it takes. No, it was already cached, sorry. So it didn't really build it, it was already built. Anyway, so if we look at here, well, yeah. So this is the function, so JLink 3. Again, if we look at that function, sorry, the wrong one. Yeah, that's why it was so fast. Well, it's fast anyway. So dive. You see here that basically, so we don't even have an operating system. We're starting from a scratch image. We have a 16 megabyte executable, and that is basically our function. That include so the function itself, but also given that we're starting from Java code, the code expects to have, for example, memory management provided by an underlying platform. So Graal embed in that native binary substrate VM to provide those capabilities that are needed by our code. And we still have this 19 kilobyte shared object. So again, that's basically how it works in FN. So low latency, high performance when it comes to serverless Java. I think that we have all the tricks and techniques that we should leverage to provide the latency that we do expect. The last point that I want to quickly discuss is the ongoing evolution of the JVM ecosystem. So you know that every 6 months we have a new Java release. So today is Java 12. In a few months from now, it will be Java 13. You know that we have Java the language, but we also have Kotlin, we have Groovy, and so on and so on. Not only that, we also have projects such as Graal, for example, that runs on top of that runs within that ecosystem. So that's why we have added this init image capability within the platform. It basically allows us to easily support that rich ecosystems. So you already saw me using this capability for JNation and Graal. And basically, what I'm doing when I'm what I'm doing here. So init image, and then I need to specify a Docker image that will provide all the artifacts for my function. So for example, Java 13 init. So what I've created here is the Java 13 function. So if we look at the code, well, it's really a Java 12 because there's nothing specific in here for Java 13. But to prove you that it's real Java 13, so we can do that. System get property. No, so not the vendor version. Oops. And yes, something that I was told when I started to program is that I need to use meaningful variable name. So now I can do variable in Java. Again, don't do that in your code. Oops, sorry. So if we deploy that guy, and if I didn't make, oops, JNation 13, let's see. Oh, I should have skipped the push, but it won't take that long, so nearly there. Now I invoke that Java 13 function. Okay, fn invoke JNation Duke 13. If everything goes well, yes, 13 early access. So it basically proves that indeed my serverless function is running on top of a 13 JVM. Obviously, it's still early access given that Java 13 is not out. So init image basically gives us the ability to support that rich ecosystem. And that's something that you can also use by yourself to add support for other language. Someone, for example, has provided .NET support a few weeks ago using that capabilities. So rich JVM system, yes, that's something that we can do. So serverless Java, does it have a future? Absolutely. We think that with OpenJDK, with Graal VM, Java has a bright future within the serverless space. And today I've used FN because we are working on FN, but there are other fast platforms that are basically using the same underlying projects, such as OpenJDK and Graal VM. So we are really at the beginning of Java within the serverless space. So the call to action, give it a try. Everything is free. The only thing that you need is Docker running on your machine, and then in less than 2 minutes you will be up and running with your first function. And if you like it, please give us a star. It's free, and those days, it's an important metrics. And I will just quickly conclude by mentioning Oracle Functions. So it's Oracle Managed Fast Platform that under the hood is using FN. So if you don't want to deal with running the platform by yourself, well, have a look at Oracle Function that has been announced at KubeCon Seattle, and it will be shortly available, and there will be a free tier. So you will be able to use the platform for free up to a certain level. And with that, I'd like to thank you for your time. And we have 1 minute and 15 seconds for questions. So are there any questions? Yes?
How much can you reduce the container? Sorry. How much can you reduce the container with Kotlin, given that Kotlin introduces an overhead?
So that's something I didn't mention. We have the ability to do Kotlin serverless function, but then we rely basically on the Java FDK. So we won't go below what we can achieve on the Java FDK side. And I'm not sure that we can use Graal those days with Kotlins. So I would assume that if we use Alpine, we would be on the 45 megabyte size for everything, which is quite good. I mean, if you look at, so if we look at Graal, Graal basically gives us the size that we have with native, such as Go. But that's basically roughly 20 megabytes. That's, if you take a serverless Go function, it's between 15 and 20 megabytes. We can achieve those numbers with Graal, but if we are using JLink and Alpine, we are 40 megabytes, which is basically another 20 megabytes. It's 2 times the size, but it's not that big of a deal either. I mean, we are not in the 100 megabytes size. No? Well, anyway, I will be here for the rest of the day, so obrigado.